Good afternoon, class. We are going to talk about our next section, which deals with the area of a triangle. And we're already familiar with where we found the area we knew is 1/2 base times height, or if we did BH over 2, either way. We know that formula for area, but now we're going to use what we know from geometry using our sines. We've talked about law of sines, law of cosines. So how can that help us out in solving for the area of a triangle? Let's take a look at this triangle. Suppose I say triangle ABC, and it has side lengths of lowercase a, b, and c. So let's look at how we can use this to solve. Now, in this one, we have a variable h, where that's the height. We're not quite sure what h is, but maybe we can solve for h to determine what h could be in terms of our variables. So remember, our area equals 1/2 base times height. Well, now let's solve for h so we can figure out what h is in terms of variables. Well, we know with our triangle here, if we have triangle, let's try this triangle. If we do triangle A, B, and let's try another one. Let's add a new coordinate point in here where my height comes down. I'm going to call that vertice capital D. So now I'm going to look at triangle A, B, D. Or I'm sorry, back that up. Let's go A, D, B. A, D, B. Alright, if I look at my triangle ADB, so I'm looking at this triangle here on the left. Well, now if I wanted to solve for that, I know that this is a right triangle. So I can use, well, I know sine of A is going to be equal to h over c. Remember from our SOHCAHTOA, the sine is opposite over the hypotenuse. Well, the opposite's h, my hypotenuse is c. So now sine of A would equal h over c. Solving for h, if I multiply both sides by c, I will have c multiplied by sine of A is now going to be equal to h. So let's use that h to plug back into our formula here on the left. So I could say now my area is going to be equal to 1/2 multiplied by my base multiplied by my new c sine of A. Okay, now we can use that formula now to solve for the area of our triangles. And so in this triangle we have 1/2 BC times the sine of A. We could also have that the area equals 1/2 AC sine of B, and we can also have it be 1/2 AB multiplied by the sine of C. So let's take a look at an example. Say we have this triangle. I'll call it triangle ABC, and our units on each side are in centimeters, and it gives our angle of 60 degrees. So we want to find the area of this triangle. So let's use our new formula. So we know that area is going to be equal to 1/2. Now, which sides do we use? Do we use the 10, the 8.5, 10, the 7, 8.5, and the 7? Well, we're always going to use the included angle, the sides on the included angle. So we need to look at only the 10 and the 7 because 60 is considered our included angle. So I know I'm going to use sine of 60, and then my sides are going to be 10 and 7. So when I do this, 1/2 times 10 times 7 times the sine of 60 gives me 30.3. And let's pay attention to our units. That's centimeters squared because we are dealing with area. So the big thing here is to understand, okay, which sides do I use? Well, I'm given one angle of 60 degrees. That's my included angle. I need to use the sides that are adjacent with that make up that angle. So 10 and 7 centimeters are the sides that I will use. Let's take a look at one more example now. Maybe a problem where we're given what the area we need to solve for the angle theta. So in this problem, we have an angle theta, and that is our included angle, and our sides are 17 and 20 meters. Well, we need to be given one additional piece. Let's say now our area is going to be equal to, we'll say 110 meters squared. Alright, so now we can set up our equation. We'll have 110 is going to be equal to 1/2. Our sides are 17 and 20 multiplied by sine of some theta. Now to solve for this, I can divide by each side, so I'm going to say 110 divided by 1/2 multiplied by 17 multiplied by 20 is going to be equal to my sine of theta. When I work this out on the left, I'll have approximately 0.64 equals the sine of theta. And now, how do we solve for this? Remember, to solve, I have the sine of some angle equals 0.64. To solve for this, I have to do the inverse sine. So sine inverse of 0.64 is going to get me theta. And when I work that out, theta is going to be approximately 40.32 degrees. Remember, we're solving for an angle. So in this, using this formula, we can solve for an angle to find the area, or if given the area, we can find the angle, or if given the angle, we can find the area. So take a look at these two problems if you're still not sure. Otherwise, come to class with any notes, any questions, and we'll do a few more problems in class.